This video looks at integration with partial fractions. We extend the method that you learned in your Maths A-level by adding in 3 new types of questions. Question 1 involves the difference of 2 squares. Question 2 uses an example similar to the one that you have in your notes here. You'll notice we have a linear bracket and a quadratic bracket. Now the quadratic bracket cannot be factorised, so we deal with it using this format here, and that's something that you need to learn, so add that onto your notes. So let's have a look at the examples. Question 1 I've done already, and we'll talk through the method. Let's move that up. So this one is asking us to prove a result where we've been given the fraction 1 over a squared minus x squared. As you'll see, we have the difference of 2 squares. We will work through the partial fractions by working with the difference of 2 squares, and I've got the working here. Apart from the fact that we've got a difference of 2 squares, the working is identical to that you have met already. So we would multiply through so that we're working with this equation here and letting x equal to a and minus a, so that we can evaluate a and b, the constants that we've introduced as part of the partial fractions. So we have 1 over 2a for both of them. Subbing in to our integration with the partial fractions, it's much neater if we take the 1 over 2a out of the integration sign. So we have that at the front as a constant, and then we have 2 fractions that we are familiar with. We have 1 over 2a times our 2 log results. You'll notice that we get a minus here in the middle because we are applying chain rule backwards, and the minus here creates the minus here when we multiply by, divide by the differential. We then combine using laws of logs to obtain the required result. So that is question 1. Let's move on to example 2, which allows us to see how the format that we've got at the top of the page works. So I've got my question and I've split it into partial fractions with bx plus c on top of the quadratic that I cannot factorise. However, I'm expanding in the normal way, so I've got 2x plus 12 over x plus 1 and x squared plus 9, and that's equal to a over x plus 1 plus bx plus c over x squared plus 9. Therefore, 2x plus 12 is going to be a times the x squared plus 9 plus bx plus c times by x plus 1. Now, the work to obtain the values of a, b and c is a little bit more onerous than the ones that you've met already. So we just need to try and make life as easy for ourselves as possible. Let's put x equal to -1, which will allow that bracket to be 0, and will allow me to find a. So if I do that, I sub in here and I get 10 equals, subbing in here, I will get 10a. So therefore a is 1. Now, There's no obvious value for me to sub in that's going to allow me to find both b and c, so I'm going to do some comparing of coefficients. That's going to involve a bit of multiplying out. However, I already know a, so that will make the algebra a little bit more straightforward. So we've got 2x plus 12. A is 1, so that gives me x squared plus 9. And then multiplying out these brackets, I'm going to get bx squared plus bx plus cx plus c. Let's consider which coefficients are going to be most useful to me. If I consider x squared, I'm going to get directly to b. So coefficients of x squared, there aren't any on the left, so 0 is going to equal 1 plus b. That gives us b as minus 1. Now I could go on and consider the x's, or I could independently consider the constants. So the constants will take me directly to c, so I have 12 equals 9 plus c, so c is 3. So I now have my partial fractions, and I can write my integral I as the integral of 1 over x plus 1 plus I've got 3 minus x over x squared plus 9 dx. I know how to integrate that one. This one is one that I need to split into 2 fractions to allow me to integrate. So I've got 1 over x plus 1 plus 3 over x squared plus 9 minus x over x squared plus 9 dx. I know that's going to give me a natural log. This is also going to give me a natural log because if I differentiate x squared, I'm going to get 2x. This one is in a format that I have already met. It's one of my inverse trig integrations, and I will be referring to the formula book for this one. So, a natural log of x plus 1 plus 3 times, it's an arctan, so it's arctan, and it's x squared plus 3 squared, so that means I need x over 3 here, and I need to be dividing by 3 here. And then I've got minus, it's the log of x squared plus 9. However, that will require me to have a 2 here. I haven't got a 2 here, so I need a half. And then we add on c. I can then tidy up. I have arctan of x over 3, and I combine my logs using laws of logs. So I've got the log of x plus 1 minus the log of x squared plus 9 to the half plus c. So that gives me arctan x over 3 plus the log of x plus 1 over square root of x squared plus 9 inside the modular signs plus c. And that's my integration. So a slightly more complex form of my partial fractions, resulting in an integration where I need to use the techniques that I've met, involving splitting the fraction, that then allows me to use a log and an inverse trig integration. So that's question 2 completed.